Hello, wonderful people. It's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my physics playlist. In previous videos, we talked about an introduction to physics. We talked about fundamental physical quantities versus derived physical quantities. We talked about the measuring units. We talked about scalars versus vectors, distance versus displacement, and speed versus velocity. Today, we'll talk about acceleration. If speed was the rate of change of distance, and if velocity was the rate of change of displacement, then acceleration is the rate of change of velocity. Delta V over delta T. Is acceleration a fundamental physical quantity or a derived physical quantity? It is derived. Derived from whom? From velocity and time. Is acceleration a scalar or a vector? It is a vector, meaning it has a magnitude and a direction. So there could be positive acceleration or negative acceleration, also known as deceleration. Positive acceleration means you're speeding up. Negative acceleration means you're slowing down. So when you start driving your car, in the beginning you are resting, motionless, and then you start driving, you start speeding up. This is acceleration. But when you see a stop sign or a red light, what do? You come to a stop. You decelerate until you stop. Positive acceleration, negative acceleration. What is the measuring unit of acceleration? Meters per second, or meters per second square. Click the like button, click the subscribe button, and let's get started. Before you watch this video, please watch my video titled Speed versus Velocity. Speed is the rate of change of distance. Velocity is the rate of change of displacement. Distance is a scalar. Displacement is a vector. Therefore, speed is a scalar and velocity is a vector. A scalar divided by a scalar will give you a scalar, speed. But a vector divided by a scalar will give you a vector, velocity. So we can say that speed is derived from distance and time, but velocity is derived from displacement and time. Velocity. Did you know that the word vélo in French means bike? Oh, which is fast. This video is part of my physics playlist, but I also have a biology playlist: general chemistry, organic chemistry, biochemistry, anatomy, physiology, pathology, immunology, pharmacology, you name it. Scalars versus vectors. For the gazillionth time, scalars have magnitude only, no direction, so there is no such thing as a negative scalar and positive scalar. But vectors are different. Vectors have both a magnitude and a direction. This direction could be positive or could be negative. Example of scalars include distance, but vector is displacement. So distance is a scalar, displacement is a vector. Speed is a scalar, velocity is a vector. Time is always a scalar. Where is acceleration? It's here. Acceleration is a vector. It has both a magnitude and a direction. And we have talked about all of these before. Get your pencil and doodle with medicosis. What is speed? Speed is the rate of change in distance. So it's delta D, distance, over delta T, time. How about velocity? Velocity is not distance, it is displacement. You can write it as delta X or delta D. Just you have to know that this is displacement, not distance, over delta T, time. How about acceleration? It's the change in velocity over the change in time. The more you write down these equations, the more likely that you're gonna remember them on your exam. Speed is the rate of change of distance. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. Speed is delta D, distance, over delta T, time. Velocity is delta X, displacement, over delta T, time. Acceleration is delta V, velocity, over delta T, time. Speed is the rate of change of distance. Anytime you see this word, the rate of change, it means there is delta T in the denominator. Change of what? Of distance. So there is delta D upstairs. How about velocity? The rate of change, I know what that means. It means delta T is downstairs, of displacement. So there is displacement upstairs. Acceleration, the rate of change, meaning there is delta T in the denominator, of velocity. So there is delta V upstairs. Now, since this series is geared more towards students studying for the MCAT or the DAT exam, let's make it medical. You know, there is a test called ESR in medicine, erythrocyte sedimentation rate. It is the rate of sedimentation of the erythrocyte. Erythro means red, cyte means cell. Referring to whom? Referring to your red blood cells, or erythrocytes. You will recall that your blood is made of plasma and cells. The plasma is water and proteins. We call them plasma proteins like albumin and globulin. As for the blood cells, you have red blood cells, white blood cells, and platelets. Red blood cells are in millions. Platelets are in hundreds of thousands. White blood cells, just thousands. So red blood cells are the most numerous cells in your blood. If I take a blood sample from your vein, it's gonna look like this in a test tube. But if I leave it for an hour or two, guess what happens? The red blood cells have more density, so they sink downstairs. They sediment. They are heavier. So they sediment like this, accumulating in the bottom of the test tube, leaving the plasma. On top, we can measure how fast your red blood cells sediment downstairs. And this is called the erythrocyte sedimentation rate. Definition: it is the rate at which the erythrocytes sediment and sink to the bottom of the barrel, the test tube. If this is the rate at which erythrocytes sediment, you can bet the rent money that there is delta T downstairs. Okay, and what should I put upstairs? Erythrocytes sedimenting. They descended from here to here, from there to there. So you can measure this distance. Oh, it's a distance. Yeah, so it's the change in distance over the change in time. But you have to measure the distance from the top of the test tube until the line where you find the demarcation between plasma and red blood cells. Here. Measure this distance. Let's say it's 10 millimeters per hour. Then that is your ESR, 10 millimeters per hour, meaning my red blood cells descended by 10 millimeters in 1 hour. 10 millimeters in 1 hour. It's the rate at which red blood cells descend and sediment. So now acceleration is what? It's the rate of change of velocity, delta V over delta T. Change in velocity meaning the difference between the final velocity and the initial velocity. How about delta T? Final time minus initial time. Let's abbreviate these. Final velocity is V2. Initial velocity, you can call it V1. You can call it VI for initial. You can call it V0. I don't care. And then you have final time minus initial time. You can say T2 minus T1 or TF for final minus TI for initial, or TF for final minus T0 for initial. Now let's practice with some numbers. Suppose that you were driving a car and your speed increased. You're accelerating from 5 kilometers per hour to 10 kilometers per hour. So what's the final velocity? 10 kilometers per hour. And what's the initial velocity? 5 kilometers per hour. 10 minus 5 is positive 5. So your acceleration will be a positive number. Yeah, because you're speeding up. Makes perfect sense. Conversely, suppose that you were driving a car, but now you're slowing down from 10 meters per second to 5 meters per second. What is your final velocity now? 5. And what's the initial one? 10. 5 minus 10 is how much? Negative 5. Giving me a negative acceleration or deceleration because you're slowing down. So when you're speeding up, the acceleration is positive, but when you're slowing down, your acceleration will have a negative sign because acceleration is a vector. Get your pencil out. All right, let's draw this nice graph. Okay, what is this? Well, this means nothing until you tell me what's on the x-axis and what's on the y-axis. So the x-axis has time and the y-axis has displacement. So what is this? Rise over run will give me what? Rise over run will give me delta x, the change on the y-axis, over the change on the x-axis, which is delta t. So delta x over delta t, the change in displacement over the change in time. What the flip is that? This is velocity, not speed. No, not speed, because I did not say distance over time. I said displacement over time. So this slope right here equals velocity. When the line is going up as a straight line like this, what do you call this? Uniform velocity or non-uniform velocity? Answer, this is uniform or constant velocity. Conversely, let me draw another graph like this. You also have displacement on the y-axis and you have time on the x-axis. But this time, the graph looks like this. Now, what do you call this? Constant or uniform velocity? Or what do you call it? Non-uniform variable velocity. Answer, this is non-uniform or variable velocity. Why? Because it's not a straight line. It's the line that started slow and then accelerated, and accelerated some more. How do I confirm that this is uniform velocity and this is non-uniform velocity? Easy. You will need to measure and find the slope. Okay, so for the first one, find the slope of this line right here. Find the slope of that line right here. Find the slope of that line right here. You'll find that this slope is exactly the same as this slope, which is exactly the same as this slope. And this is the definition of uniform constant velocity. However, look at this curved line. If I find the slope for this line, and the slope for that line, and the slope for that line, of course it's obvious just by looking at it that this is less steep, this is moderately steep, and this is very steep, which means low slope, intermediate slope, very high slope. Because here the velocity was low, then it gets higher and higher. But what if I want not just the slope of a piece? How about if I want the average velocity in the entire thing? If you want the entire thing, you have to start from the beginning and end at the end. And then you draw the lovely triangle like this. And what is the slope again? The slope is always rise over run. Rise over run. Yes, delta y over delta x. The change on the y-axis over the change on the x-axis. What is the delta y here? It's the change in displacement. And what is the delta x? It is the change in time. Similarly, if you want the average velocity here, you gotta start at the beginning and end at the end, and then you give me that beautiful line. Average velocity is the slope of this purple doofus right here. Oh, so how do I get this? It's still rise over run. So you need the rise, which is the change on the y-axis over the change on the x-axis. The change on the y-axis is the change in displacement. The change on the x-axis is the change in time. So if you're getting the slope of this green segment right here, this is called instantaneous velocity. Here's another instantaneous velocity, which is different from the first. And here's a third instantaneous velocity. But this is the average velocity. And we have talked about all of this in great detail in the last video in this physics playlist. So just like velocity could be uniform velocity or non-uniform variable velocity, the same exact thing applies for acceleration. You could have uniform acceleration or non-uniform acceleration. Let's define uniform or constant acceleration. Okay, so per time, what's going to happen? The object changes its velocity with equal amounts, hence uniform. Because what is acceleration again? Acceleration is delta v over delta t. So per unit time during equal time intervals, the velocity will change in equal amounts, meaning in the first second, I started as 1 meters per second. And then in the second second, I was at 2 meters per second. So I'm accelerating. At the third second, I am 3 meters per second. At the fourth second, I am at 4 meters per second. What's happening is that in each second, which is an equal time interval, second after second, velocity increases in equal amounts. Plus 1, add another 1. But in the non-uniform acceleration, during the same time intervals, let's say seconds, the object changes its velocity with unequal amounts. Unequal is non-uniform or variable acceleration. Example, suppose that here is the first second, third second, and fourth second. Okay, in the beginning I started at 1 meters per second. Okay, I can live with that. Then I went to 2 meters per second. Okay, so the increase is just 1. You added another 1. And then what? Then my velocity became plus 4 meters per second. Then my velocity became plus 8 meters per second. So this was a rise by 1. This is an increase of 2, and this is an increase of 4. Non-uniform acceleration. So which car is speeding up? The answer is both. This is speeding up, this is speeding up. This has positive acceleration, and this one has also positive acceleration. But here, the positive acceleration is not just positive, but uniformly positive. Equal amounts of increase. But here, the increase is unequal. It is non-uniform. And to belabor the point, because it's worth belaboring, if they give you a graph like this, just look at the axes first. Here is time, okay. If here we have distance, then the slope of this beautiful line right here represents what? It represents speed, okay? But what if we have displacement here instead of distance? Then this will be velocity. Because distance over time is called speed, but displacement over time is called velocity. Gotcha. But what if the y-axis is velocity and the x-axis is time? Velocity divided by time is the definition of acceleration. When the slope is going up in a straight line, this is uniform. Could be uniform speed, uniform velocity, or uniform acceleration. But if the line is going like this is the definition of non-uniform. Non-uniform speed, non-uniform velocity, or non-uniform acceleration, depending on your axes. Acceleration types. There is positive acceleration when you're speeding up. There is negative acceleration or deceleration if you're slowing down. But what if I'm moving at constant velocity, neither speeding nor slowing? Then this is called zero acceleration. Let's draw a graph for each. Okie dokie, okie dokie, okie dokie. Here is the time, and it's called change in velocity over change in time. So v and t. Amazing. Positive acceleration, that's easy. Negative acceleration, also easy. And zero acceleration is like this. What does that mean? It means that the velocity is neither increasing nor decreasing. It's just constant. As time passes by, the velocity does not change, does not go up or down. But as time passes by, velocity goes up. As time passes by, velocity goes down. And there you go. Can you please pause and tell me what each one describes? First, velocity over time. This is acceleration. It's a positive straight line, so this is positive uniform acceleration. How about this? This is negative acceleration, also uniform, also known as deceleration. And this is constant acceleration, neither increasing nor decreasing, neither accelerating nor decelerating. And there you go, each type of acceleration with its graph. Positive acceleration, negative acceleration, and zero acceleration. Here you have a positive slope. Here you have a negative slope, and here the slope is zero. Because what's the angle that I make with the horizontal? There's no angle, the angle is zero. And the slope is always tan of the theta. What is tan 0? Tan 0 equals 0, so the slope here is 0. But this angle is about 45, so to speak. What is tan 45? Tan 45 is positive 1. So this is a slope of positive 1. And here, what's the name of the angle that I made with the horizontal? It's a negative angle. I did not go up, I went down like this. Let's make it a negative 45. What is tan negative 45? Answer, it is negative 1. So the slope here is about negative 1. Another student told me, well, I do not want to pick this angle. I want to pick the angle that I make with the horizontal like this. I want all of this angle, okay? If you want all of this angle, follow me, please. All right, how do we do this? Well, this is 90. This is another 90. So this is 180. Plus another 90 will give me 270. Plus 45 is 315. What is tan 315? Answer, guess what? It's also negative 1. Ta-da! Some pearls for the pros. These are extremely important. If the acceleration has a positive sign, you're speeding up. If the acceleration has a negative sign, you're slowing down. But if acceleration is 0, you are moving at a constant or uniform velocity. Super important. Acceleration is what? Delta V over delta T. And what is delta V? It is V final minus V initial over delta T. If you are starting from rest, of course, during rest, the initial velocity is 0. So VI is 0. But if you're coming to rest, which means your initial velocity was something, but your final velocity is 0. So if my final velocity exceeds the initial velocity, it means that I'm speeding up. For example, I went from 0 meters per second to 5 meters per second. Since the final velocity is greater than the initial velocity, I am speeding up from 0 to 5. But let's say that I'm slowing down from 5 meters per second to 0 meters per second. What is the final velocity? 0. What's the initial? 5. Final velocity is less than the initial velocity, which means that I am slowing down. So acceleration will have a negative sign. But what if the initial velocity equals the final velocity? Then I'm neither accelerating nor decelerating, and the A will equal 0. Acceleration is nil. If velocity and acceleration have the same direction, then velocity and acceleration will have the same sign. For example, positive and positive, or negative and negative. And what does that mean? This means that I'm accelerating, I'm speeding up. But if velocity and acceleration have opposite directions, meaning one of them is positive and the other is negative, or one is negative and the other is positive, this means I am decelerating, and this is super important. If you can just study your equations and medicosis pearls for the pros, you'll be in a very good shape. Plus, practice, practice, practice as many problems as you can. You can download these wonderful, colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Be very careful of the negative signs. Here are your directions: north, south, east, and west. Usually we give north and east positive direction, which means we have to give south and west negative direction. For example, if I started walking east, 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 that will be a positive sign. Then after this, I walked west, 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 that will be a negative sign. So a negative sign on a displacement, it means that I'm moving in the opposite direction. But of course, distance is a scalar, so distance cannot be negative because distance does not have a direction. What if velocity is negative? It means that I'm moving in the opposite direction. For example, if I was driving my car east like this, it has a velocity, a positive velocity, but then I drove in the opposite direction, that will have a negative sign, meaning I am moving in the opposite direction. But what if not the velocity, but the delta V is negative? It means that the velocity is decreasing. Why? Because what is delta V, please? Delta V is V final minus V initial. If delta V is negative, it means that V0 exceeds V final, meaning the time slowing down, the velocity is decreasing. Example, suppose that I started at a velocity of 5 meters per second and then I ended up at 2 meters per second. Which one is the initial velocity? It is 5. And what's the final velocity? It is 2. 2 minus 5 will give me a negative number because I'm slowing down. But what if acceleration has a negative sign? Well, it could be acceleration is negative because velocity is negative. Remember that acceleration is velocity over time. So if delta V is negative because I'm slowing down, therefore A will be negative because I'm slowing down. Or acceleration could have a negative sign if acceleration is in the opposite direction of velocity. For example, velocity is a positive sign, but acceleration is a negative sign. For example, if I am moving east, my velocity will be positive. But let's say that I'm moving east, but I'm slowing down while moving east. Your velocity will be positive, but your acceleration will be negative. When velocity is positive, acceleration is negative, it means that you're slowing down. So this is the meaning of negative signs. Don't forget, they only apply to vectors, not scalars, because scalars do not have a direction. If you find these videos to be helpful, please consider supporting my channel by buying me a coffee. Go to buymeacoffee.com/medicosis. Let's practice. Here is a problem for you. Please pause and try to answer this yourself. Okay, a car started from rest. Whenever you start from rest, it means what? Your V initial is 0 until you reach a velocity of 90 kilometers per hour. So V final is 90 kilometers per hour. But look, they give me this in kilometers per hour and then 10 seconds. So let's convert kilometers per hour to meters per second. 90 kilometers per hour. To convert kilometers into meters, what do? You multiply by 1,000. As for 1 hour, what do? 1 hour has 60 minutes and each minute has 60 seconds. An easier way to do all of this is to multiply the kilometers per hour by 5/18 to get the answer in meters per second. And this will give me 25 meters per second. But if you want to convert meters per second to kilometers per hour, you do the opposite. You multiply by 18/5. Notice that anytime you convert kilometers per hour to meters per second, the number will decrease a little. I went from 90 to 25. 25 is closer to 1/4 of 90. It's not quite quarter, but it's there. Okay, so I have the V initial, which is 0. I have the V final, which is 25 meters per second. And what else do I have? I have the time. My t is 10 seconds. What do they want? They want the acceleration. That's easy peasy. Acceleration is delta v over delta t. What is delta v? V final minus v initial. And what is delta t? It's 10 seconds, baby. V final is 25 meters per second minus V initial, which is 0 meters per second. So this is just 25 over 10. 25 what? 25 meters per second. And 10 what? 10 seconds. So the answer has to be in meters per second squared, or meters per second. What is 25 divided by 10? That's 2.5 meters per second squared, and this is the acceleration. That's okay for the mediocre student, but if you're an excellent student, remember that acceleration is a vector, so you better say positive 2.5 meters per second squared. That's a better answer. It signifies to your teacher or professor that you actually understood it. Same thing for velocity, by the way. Let's make it positive 25 meters per second because we are super sophisticated to the point of being stupid. So there you go. Here is the same answer in color. Please take a moment to pause and review. Notice that in this case, my velocity was a positive number and my acceleration was also a positive number. If velocity and acceleration have the same direction, what does that mean? Well, if they have the same sign, it means that you are accelerating. And that's true. The car in the previous problem was accelerating, and the acceleration was positive 2.5 meters per second squared. So this is what we mean by if velocity and acceleration have the same sign, positive and positive, or negative and negative, it means that I am accelerating. Notice in the previous problem we started from rest, so V initial is 0. Notice from the previous problem that V final exceeded the 0. Yeah, because we're accelerating. Acceleration had a positive sign because we're speeding up. Acceleration and velocity were both positive. Yeah, because we're speeding up. Here's another question for you. Which of the following graphs represent a stationary or motionless object? Give me something static. What do you think? First, you look at the axes, y-axis and x-axis. Displacement over time, this slope equals velocity. Velocity over square root of time. Well, velocity over time is acceleration. So this is a weird way to refer to acceleration, but it's not going to be a perfect method. How about displacement over time? The slope of this line is velocity. How about velocity over time? The slope of this line is acceleration. Here, velocity is a straight line in the positive direction. This is uniform velocity. This object is moving. So A is incorrect. Forget B because that's weird. Let's look at C. Displacement over time. The slope is velocity and this slope is 0. This means that velocity is 0. Oh, this is motionless, baby, because it has no velocity. But how about if the acceleration is 0? This means that the acceleration is 0, i.e., I am neither speeding up nor slowing down. I am moving at a constant velocity, but I am moving nonetheless. So D is not correct. The correct answer here is C. So what does each of these graphs represent? That's the same question. This one, I'm moving forwards over time. Velocity is positive. Here, I am moving at a constant velocity not per time, but per square root of time. But I'm moving. Here, the slope is velocity and this slope is 0, which means I am motionless over time. But here, the acceleration is 0, which means I am moving at a constant velocity, but moving. Here is another question for you. Which graph represents an object moving at uniform or constant velocity? Please pause. Look at the axes. Velocity over time, this is acceleration. Velocity over time, this is acceleration. Displacement over time squared, this is kind of similar to velocity, but not quite. And displacement over time, this is velocity. I'm going up, so this acceleration will take a positive number. This slope is 0, so here the acceleration is 0. And here, velocity is going up, and here, velocity is 0. So what is uniform or constant velocity? It means that the velocity, look at this, it's neither going up nor going down. Okay, so the answer is B. Why not A? Because A is accelerating, and when you're speeding up, that's not uniform velocity, that's speeding up. So A is not true. Well, for velocity to be constant, you want displacement over time, not time squared. That's not constant. This is not a linear relation, this is an exponential one, which means C is not correct. Here, velocity is 0. If this distance is 5 meters, well, you're not moving to 6 meters or to 4 meters. You're not moving at all, period. This is a motionless subject, so no. So let's review. This object is accelerating. This object has 0 acceleration, meaning it's moving at uniform or constant velocity. Here I have a linear relationship between displacement and time squared, which means the relation between displacement and time alone has to be nonlinear. It is exponential, not linear, meaning it's non-uniform. If it's not linear, it's non-uniform. And this object is not moving. How about this question? Which graph represents an object moving at uniform or constant acceleration? Please pause. Okay, first the axes. Acceleration over time. Okay, this acceleration is neither going up nor going down. So you can call this 0 acceleration. It is constant acceleration, but it's acceleration nonetheless, which means this object is speeding up, and the line is a straight line, so A is probably the correct answer, but let's keep trying. How about velocity over time? Velocity over time, this is acceleration, and here acceleration has a slope of 0. This is constant velocity over time, and not constant acceleration, so B is incorrect. How about C? Displacement over time is velocity. This is going up. This is uniform velocity, not uniform acceleration. So C is incorrect. How about this? Velocity over time is acceleration. This is acceleration in the positive direction, but it's non-uniform, making D incorrect. So the correct answer has to be A. Because A represents uniform or constant acceleration, B represents uniform or constant velocity, C is also uniform or constant velocity, and D is non-uniform or variable acceleration. If both directions of velocity and acceleration are negative, therefore what? Please pause. Well, velocity is negative and acceleration is negative. Negative and negative, meaning they are in the same direction, they have the same sign, which means the object is accelerating. The velocity is going up. Next, if a ball that was rolling on a surface starts to slow down until it stopped, then the acceleration is what and the velocity is what, respectively? Positive, negative, negative, positive, 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 or negative, negative. Please pause. Well, I am slowing down. I am decelerating, meaning that acceleration and velocity have to have opposite signs, either positive and negative or negative and positive, which means that C has to be incorrect and D is also incorrect. So I'm between A and B. Rolling on a surface. So let's just draw a surface. And here is the ball rolling. We'll assume that we're moving in this positive direction, but I'm slowing down. So I'm still moving east or still moving to the positive x-axis. So I will say that velocity will be a positive, but since I'm slowing down, acceleration is negative, and I will go with B. They are testing you on this point right here. If velocity and acceleration have opposite signs, for example, velocity is positive but acceleration is negative, it means we're decelerating, just like the ball that came to stop. Coming up next, a car was moving at 20 meters per second. When the brakes were applied, it slowed down till stopped. After a while, as shown. So I'm moving until I stopped. From this diagram, what's the average velocity? How about the acceleration? Please pause. Remember, for average velocity, you have to start at the beginning and end at the end. What is velocity, please? Average velocity is the difference in displacement over the difference in time. So delta D over delta T. What is the difference in displacement? You need final minus initial. How about for time? Same thing, final minus initial. Okay, let's go. What is the final displacement? Here, it's 100. And what's the initial? Here, it is 0. So 100 minus 0, or simply 100 meters. And what's the time? What's the time final? 10 seconds. And initial, 0 seconds. So it is 10 minus 0, or simply 10 seconds. So 100 over 10 equals 10 meters per second. That's the average velocity. For the sophisticated students, velocity is a vector, so you better say positive 10 meters per second. Next, acceleration. What is acceleration, please? Acceleration is delta v, velocity, over delta t, time, which means I need velocity final minus velocity initial over t final minus t initial. You can also say v2 minus v1 over t2 minus t1. Same thing. What is velocity final? Well, I stopped finally, so it has to be 0. What is the velocity initial? 20 meters per second. Amazing. 0 minus 20 is negative 20 meters per second. And what is time, please? Well, t2 is 10 seconds and t0 is 0. So 10 minus 0 is 0. Okay, you can cancel this 0 with this 0. And then negative 2 over 1 is negative 2. Negative 2 what? Meters per second, or meters per second square. Notice here that acceleration has a negative sign. Why is that, Captain Obvious? Because I am slowing down and not speeding up. Hence the negative sign. Notice also that velocity had a positive sign. When velocity is positive and acceleration is negative, i.e. they are in the opposite direction, one is plus, one is minus, it means what? It means that we're decelerating. See, physics makes so much sense once you understand what the flip you're talking about. That's why I will rename my channel into Physicosis Perfectionalis. And here is the same answer in color. Velocity is a positive, acceleration is a negative. They are opposite because we're slowing down. Let me tell you how you recognize uniform deceleration from a table. So at 0 time, I did not move any, but my velocity was 20 until I stopped. So let's do delta v over delta t to get the acceleration. What's delta v? In the numerator, it's 18 minus 20. Denominator, 2 minus 0. So numerator is 18 minus 20 because that's the delta v. Denominator is 2 minus 0. 18 minus 20 is negative 2. 2 minus 0 is simply 2. Negative 2 divided by 2 is negative 1 meters per second. How about doing it from here to here? Okay, so it is 16 minus 18 over 4 minus 2. 16 minus 18 is negative 2. And 4 minus 2 is just 2. This will give me negative 1 meters per second. And you can repeat this from here to here and from here to here. Also from here to here and from here to here. And you get the same negative 1 each time, proving that this is uniform deceleration. Why deceleration? Because it has a negative sign and I'm slowing down. Why uniform? Because it's constant, i.e. every 1 second, my velocity is decreasing by 1 meters per second. That's what it means. How about the question of the previous lecture? The two sisters A and B running toward each other where the distance between them is 100 meters. They will run towards one another until they hug one another. If the velocity of sister A is 6 meters per second, the velocity of sister B is 4 meters per second. Find the distance covered by each sister until they hug one another. Please pause and try to answer this. Again, I'll be so proud of you if you can do it. Okay, let's draw both sisters. One using a blue color and the other using purple color. Okay, which one is faster? Sister A is faster, 6 meters per second versus sister B, only 4. So if I am honest and I draw a line like this between them, they have to meet at a point in the middle. But since the blue sister is faster, therefore they will meet here, which means the blue sister, because faster, will cover a longer distance before they meet. So let's say that they will meet at this point. Now let's write down what is known. The distance between them is 100. So this 100 is the entire distance from here until the other sister. Okay. Let's call the distance for the first sister in a blue color D1 and the distance for the second sister in purple D2. I know that D1 plus D2 has to equal 100. So let me get my colors. D1 plus D2 equals 100. This has to be true. Next, what's the velocity for the first sister? 6 meters per second. And for the second sister, 4 meters per second. This is also known. What do they want? They want the distance covered by each sister. So they want D1 and D2. There are many ways to solve this problem. I'll give you 2 ways today. First, I have 2 unknowns. I do not know what D1 is or what D2 is. It's easier to work with one unknown. So let's just call everything D1. So D1 will stay D1. And what is D2? Well, D2, according to this equation, equals 100 meters minus D1. So from now on, D2 will be called 100 minus D1. And what do we know? We know that velocity equals displacement over time. For the first sister, V1 equals D1 over T1. What if I want T1 to be on one side? Let's rearrange the equation. T1 equals D1 over V1. You can do it by cross multiplication and then rearrangement. T1 is D1 over V1. How about T2? Well, it has to be D2 over V2. Notice that they will find one another, they will meet in the middle, which means T1 equals T2. If T1 equals T2, therefore D1 over V1 equals D2 over V2. And we've just agreed that we're not going to call D2 D2 again. We'll say that this is 100 minus D1. So let's write down everything we know. What is D1? D1 is unknown. Okay. What is V1? It is known. It is 6 meters per second. What is D2? I'll call it 100 minus D1 so that we're playing with one unknown, which is D1, over V2. What is V2? It is 4 meters per second. Amazing. Now I only have one unknown. I can do this. I can solve it via cross multiplication. So D1 times 4 equals 6 times all of this nonsense. So let's rearrange it. It's 4 D1 equals 6 times 100 is 600 minus 6 times D1 is 6D1. Let's get that 6D1 here with a positive sign. So it becomes 4D1 plus 6D1 or 10 D1 equals how much? 600. So D1 alone is how much? Divide by 10, you get 60 meters. So I got D1. What is D2? Well, I know that D2 has to be 100 minus D1. So 100 minus 60 is 40. D2 equals 40 meters. Now let's think about this logically. Remember that velocity is distance over time, which means the relationship between velocity and distance is direct. The greater the velocity, the greater the distance. Which sister has a higher velocity? Answer V1. And therefore, which sister will traverse a longer distance? Also sister 1, because if you're faster, you will cover more distance per time. I see here that sister 1 has greater velocity. 6 is greater than 4. Also, the first sister traversed a longer distance, 60 versus 40. And this is the first way to answer this problem. Please take a moment to pause and review. The key here is to name D2 in terms of D1. So you call it D1 and 100 minus D1. But there is another way of answering this. You know that velocity is distance over time, which means the relationship between velocity and distance is direct. Which means if the ratio of V1 to V2 is 6 over 4, then the ratio between D1 and D2 has to be 6 over 4. So let's just call D1 6x and D2 4x, so that the ratio is 6 over 4. I know that 6x plus 4x equals what? Equals 100. So if 10x equals 100, then what's the x? Each x is 10 meters. Therefore, distance 1 is 6 times 10 or 60 meters, and D2 is 4 times 10 or 40 meters. And that's another way of solving this problem. Pick what you want. Pick your poison. As you see, my illustrations are out of this world. You can download my physics notes, general chemistry notes, biochemistry notes, organic chemistry notes, physiology notes, anatomy notes, all kinds of notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Make sure to watch the videos in my physics playlist and also biology, general chemistry, organic chemistry, biochemistry, and more. To learn about how your kidney works, download my renal physiology course at medicosisperfectionalis.com. It will teach you about the glomerular filtration rate, what happens in the proximal tubule, distal tubule, loop of Henle, etc. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.